Hello, hello, hello. Thank you for tuning in. Give us just a moment here while Alan comes back with the launch of his stream, and we will begin reading night here on Ether Cosmology.
Hola, we're live.
Excellent. Thank you, everyone, for listening in here on Ether Cosmology. Thanks for tuning in for reading night number 23. Tonight, we're going to take a little detour. Well, really, there's no way to detour because we're still reading. And as the standard disclaimer goes, what this is on Monday nights we do at 9 p.m. 9 p.m. Eastern, we do reading and research live on the spot here. It's not really a presentation night or discussion night, but literally just we pick a paper, we pick a book, and we read. So it maybe isn't for everybody, but if you want to come read with us, you can go to discord.gg/ethercosmology, or just go to ethercosmology.com, click the little Discord icon on there, and you can come find us here and come read with us. Tonight, I was going through some of my LIGO resources, and I realized that I never really gave this particular paper a lot of attention. I think I looked at one or two other papers from Dongfang, or we did in the past, but this little PS thing here caught my attention, and so I thought, we should take a little peek at this paper. So that is what we're going to do tonight, and then, we'll see how it goes. So without further ado, let me take a quick drink of some ether in
Some delicious
format.
brushtail coffee.
Honestly,
which you can find at brushtail.coffee.
Honestly, I am probably going to take a little drink here from this. What was this? This was the Ethiopia Yirgacheffe that I made this morning.
Oh, that fresh Ethiopian aroma. My favorite.
Those heirloom beans. That's right. All right. So,
the good thing about heirloom beans, they're not poisoned by a multi-billion-dollar corporation.
Yeah, they're definitely not that.
Does seem right.
All right. So, LIGO spiral binary black holes failed to merge by XD Dongfang from the Wutong Mountain National Forest Park in old Shenzhen, China. One of my favorite provinces. Frequency distribution and variation law of the GW150914 waveform of a large number of ancient and distant binary merging gravitational waves claimed by LIGO are deeply studied, and the recurrence relation of frequency of GW10914 waveform with macro quantization and significance is accurately fitted. Firstly, the characteristic equation for effectively correcting the amplitude time of the waveform is proposed. The normative conditions of the numerical analysis method of the minimum solution of the characteristic Diophantine equations are determined. The new correction value of the amplitude time of the GW150914 waveform is given, and then the quantized recursive equation characterizing the frequency distribution of the signal is obtained. Secondly, the complex but clear data processing procedure for drawing the quantum theory waveform is introduced, and the standard waveform of GW150914 waveform is drawn. It is pointed out that the drawing of LIGO numerical relativistic waveform is opaque, and the conclusion is vague and lacks scientific analysis. Thirdly, the missing characteristic frequency in GW150914 waveform is confirmed, and then the reason why Hanford waveform and Livingston waveform have no corresponding band of characteristic frequency is analyzed. It is proved that LIGO's GW150914 spiral binary black holes failed to merge successfully, which shows that no matter how powerful the research team is, it is difficult to create astronomical events without any flaws. Finally, an experimental proposal to effectively test the confidence of a laser interferometer gravitational wave detector is proposed to detect the gravitational wave of a simulated spiral binary system.
Gloves are off.
What's that?
Gloves are off.
Yeah,
Drop them to the ice.
This guy is not a fan, man. P.S. LIGO made up enough lies that the gravitational wave of the merger of spiral binaries was detected because they naively believed that as long as they teased the readers and announced that the binaries in all gravitational wave events were merged, there would be no corresponding gravitational wave in the future, and it would never be possible for anyone to discover the truth of the so-called gravitational wave of spiral binaries. However, there is no perfect lie in the world. Theoretical physicists only need to master the correct theoretical knowledge of gravity and understand the precise motion law of binary stars, and they can find many fatal loopholes in LIGO's lies. What is introduced here is just one of the loopholes in LIGO's lie of detecting the gravitational wave of the merger of spiral black holes. If the story of spiral double black holes is true, it must radiate a peak corresponding to a specific frequency. LIGO is obviously very ignorant about the basic knowledge of these gravitational theories, so it is unable to carry out the necessary calculations. This unfortunate ignorance has become one of the huge loopholes in the lie of LIGO's spiral binary gravitational wave. In fact, readers can all expose the lie of LIGO gravitational wave from other aspects, and finally find out what kind of laboratory signal LIGO's so-called gravitational wave signal is simulated with. Evidence to expose LIGO lies will be more wonderful one by one. However, LIGO and its cooperative institute, how have we not read this paper before?
This is awesome.
Right.
I am digging this.
Did you write this, Stone?
Let me get out my collection of forks.
Yeah,
not only are you wrong, but here's where you went wrong. Here's how we could fix it. Here's how we can do more experiments to show you that you're wrong and I'm right.
So, however, LIGO and its cooperative institutions are likely to use the precise inferences of our paper to fabricate spikes for a specific frequency and further release false gravitational waves. Therefore, we have to keep other wonderful evidence secret for the time being, prepare for the Jedi counterattack, and finally conclude, for LIGO, there are many lies in the scientific community, and LIGO's lies, although very cunning, are the most ignorant. It can only deceive those non-real theoretical physics scholars, especially the news media.
Ooh.
Wow.
Oof.
Let's get into it.
Did he leave anybody out?
Right, dude. This guy's like, come, take away all my credentials. Kick me out of academia. Do it. I dare you. Imagine that the ancient and distant dense binaries merge frequently at a specific time, and the merged information happens to be transmitted to the Earth and captured by LIGO according to the foresight of research institutions in recent years. There will be no such opportunity after that because all spiral binary stars have been merged. This story is obviously unconvincing. Therefore, it is most appropriate to define the so-called spiral binary stars merger gravitational wave declared by LIGO as LIGO manufacturing. The vibration curves depicted by LIGO are called waveforms. The monotonic increase in frequency of GW150914 waveform is qualitatively consistent with the radiation frequency of the spiral system, and many other signals such as locomotive start also have the monotonic increase in frequency. The identification of signal wave of unknown wave source needs to compare the accurate law obeyed by physical quantities, such as the frequency of the original detection data of the signal, with the accurate law of physical quantities, such as the radiation frequency of the model wave source. However, according to the theoretical waveform, oh wow, the expected waveform is extracted from the chaotic waveform, and then the extracted waveform is used as evidence to declare that the so-called experimental observation confirms the theoretical inference. This kind of strong, twisted, chaotic logic is defined as modern advanced scientific thought only because we succumbs to the academic authority of the famous scientific research team. Mwah. Yeah. Let's give that a little highlight.
One of the boys out there.
Guy is like,
All your research team
seriously.
belong to us.
How long can its vitality last? It is a serious misunderstanding of the law of nature to put general relativity above gravitational waves, and believe that there will be no gravitational waves without general relativity. Relativity itself is not an inevitable theory to describe the laws of nature. Extraction of LIGO data completely depends... What's up?
When we get a chance, can we check out Citation 5?
Oh, yeah. Let's take a little peeky right now. Oh, it's him.
On the left. It's the first of the 4 of his papers that he quotes.
Oh, nice. Okay, respect. Let's check that out.
I wonder if that was... I think we looked at one of his... We looked at another 2021 paper of his once.
Yeah, I recognized his name. Dongfang.
But we did not look at
nothing in
this
my
one.
library.
Yeah, I don't have this one. This is the one I think that we looked at in the past. This one here, number 17.
Oh, okay.
That we may have looked at quantum laws.
Yeah, 2 right on 25 and 6.
Yeah. Anyways, hop back to where we were. Extraction of LIGO data completely depends on the waveform template of general relativity gravitational wave theory. Is that so? We found it right where we were looking for it. If the actual operation is like this and is publicized as a hard and effective work, its playful color is very strong. The so-called signal wave data is obviously not the data of real observation significance, but data that has been seriously tampered with or even fabricated and disguised. After extracting the desired waveform from the chaotic mixed waveform through the theoretical template, it is determined that the gravitational wave generated during the merger of ancient and distant spiral binary black holes, just like drawing a curve in the desert according to a function graph, taking photos, and then determining that the curve is the footprint of aliens. If a spiral binary exists, the frequency of the gravitational wave radiated by it increases monotonously. Gravity theory holds that the frequency of the gravitational wave should meet the nonlinear Blanchett equation, according to citations 15 to 16. Although the Blanchett frequency equation has no explicit function solution and it cannot be used to calculate the accurate frequency distribution law of gravitational waves, the conclusion of numerical analysis is that the frequency of GW150914 signal does not obey the Blanchett frequency equation. It can be predicted that the gravitational quantization theory represented by string theory, superstring theory, and M theory what the? M theory? Anyone know?
You don't know about M theory?
Modern theory, maybe?
Question.
I've never heard of it.
Magnetic?
Is that the one where they try to bring back God as the primary source of everything? Dude, there's literally like a new one where they're like, all right, boys, so God? Anyone? Dude, it's insane. I forget what it's called, but it might be M theory. It's something like dumb like that. I was like, wait a minute, are you for real? You're just you circled back to the thing you tried to escape.
Yeah, if anyone wants to look up M theory real quick, Go for it.
I think what you're talking about, Alan, is him theory, right? Him.
Yeah. Yes.
So superstring theory and M theory combines general relativity with quantum mechanics and cannot calculate the most basic characteristic physical quantities, such as the frequency or wavelength of the gravitational wave. Formally, if we imitate the quantum theory of the hydrogen atom to establish the quantum theory of the gravitational system, it seems that the calculation formula of the frequency or wavelength of gravitational wave, let me zoom in a little bit here,
And be given. I've got the quick definition here.
oh nice,
M theory is a theory in physics that unifies all consistent versions of superstring theory. So
oh
it's
good,
basically a catch-all.
just like
it's a
string theory
super
was,
string.
dude, that's hilarious. Of course they like string theory.
They
We're
got
still a
another
little bit
11
off.
dimensions for you.
Don't worry, we'll throw a few more dimensions on here. We'll go to superstring theory. Oh, we found we're still a little bit off. Well, we can patch that all up with some M theory.
We had 10 dimensions, but we really needed 14.
And don't forget the final step, dog, to combine it with GR and with quantum
Wicked little
mechanics.
Dang, what a showing.
Yeah. I mean, that's all you got to do, dude. Just a little divergence to infinity forever.
You gotta math the shit out of that.
So formally, if we imitate the quantum theory of the hydrogen atom to establish the quantum theory of the gravitational system, it seems that the calculation formula of the frequency or wavelength of gravitational wave can be given. However, in this way, the picture of matter cloud in the gravitational field predicted by the imitation theory is not consistent with the distribution law of planets. Well, we can just forget about that, right?
You can't be violating Kepler, buddy. Just step right on back.
No, don't worry about it, Stone. Just, we know they're out there. Don't you know that we know they're out there? So obviously they happened, and it happened the way we thought they happened.
I love that.
What is the picture of matter cloud? Does that mean that, like, you know how would that be like the quantized particle of the gravitational wave? Is that what they're saying?
Probably some, oh God, this brain fart. The probability cloud of where something might be in the cloud. I bet they're throwing that kind of math at you. Radial.
Oh,
Yeah, because he's talking about the old start of the, distribution law of planets.
it's my favorite law.
And the derived radiation frequency formula of spiral binaries does not accord with the discrete frequency distribution and variation law of GW150914 waveform. In fact, the assumptions and principles of quantum mechanics used to describe micromotion also have their specific scope of application, even do not conform to logic, and cannot be directly used to describe the macromotion law dominated by universal gravity. Bummer. If only from the perspective of the monotonic increase of the frequency of GW150914 waveform, it is claimed that this signal is a spiral binary and must be the gravitational wave generated by the merger of spiral binary black holes. Its reliability is obviously far from enough, though in-depth analysis of the frequency and amplitude distribution law of GW150914 waveform wave, it can be found that it is very likely to come from the analog device. But the COM quantization laws shown by the frequency of this signal are still of research value. It will promote understanding of the macro quantization law of variable frequency signal. This is why we take it as the experimental basis of quantum theory. So I am very happy to keep reading, but if anyone else wants to get in, I can pass it off.
Sure thing, man.
You want to take over?
You
Is that
bet.
what you're saying?
Yeah, man. You bet.
Go for it.
Now, suppose I'm just going to call it the GW because all these stupid numbers are always the same and unchanging.
Yeah, you
throughout
keep saying the
dot.
same one, yeah.
Well, let's just suppose that the GW waveform comes from a certain frequency conversion rate movement. We further study the frequency distribution law of the GW waveform. Firstly, the plausible amplitude time is extracted from the GW waveform data released by LIGO. The characteristic equation satisfied by the amplitude time or the corresponding frequency is found, and the specification condition of the minimum solution of the characteristic of the Diophantine equations is determined. Then the characteristic equation is used to accurately correct the wide peak or uncertain peak of the GW waveform and fit the quantized frequency recurrence equation according to the minimum solution of the characteristic Diophantine equations. In order to compare with LIGO's numerical relativistic waveform, the numerical drawing procedure of complex but not intended to the mystify waveform of quantum theory is provided here. That's a really weird sentence, bro. And the quantum standard waveform of the GW waveform is drawn. It is of great significance to calculate the maximum characteristic frequency of the GW waveform, because if the GW waveform back up. There you go. It comes from the gravitational radiation of spiral binary stars merge, then from the precession process to the oscillation process, the binary star must radiate at least one peak pulse corresponding to one of the characteristic frequencies. However, the characteristic pulse is missing in both Hanford waveform and Livingston waveform. It is necessary and important to find out the cause of disappearance with theoretical and experimental significance. In addition, considering that the experimental observation results should be repeatable, an experimental proposal for detecting the gravitational waves simulating spiral motion in the laboratory is also proposed. The purpose is to further confirm the confidence of the gravitational wave laser detector and increase the experience of identifying the gravitational wave through repeatable experiments. Sounds like science, boys. Okay, number 2, frequency recurrence equation of the GW waveform. The displacement of all vibration curves of LIGO is called strain. Frequency of the main vibration part of the GW waveform increases monotonously, and the main vibration part of the Hanford waveform of the GW waveform coincides with of the Livingston waveform that the positive and negative strains overturned and the time delayed 7.324218 milliseconds, as shown in figure 1. I love how he went to 6 decimal places and he's already at milliseconds. Okay,
It's
as shown in
impressive,
figure
right?
1, the real line segment indicates the correction time of the positive and negative strain peak of the superimposed waveform, while the virtual line segment represents the time of the distorted positive and negative strain peak. With the inverse time sequence number, the last positive or negative strain peak corresponding to the maximum frequency of the monotonically increasing frequency corresponds to the smallest quantum number, n equals 1. Investigating the several wide peaks of the main vibration part in the superimposed waveform, in addition to noise resulting in waveform distortion, noise may lead to waveform distortion, and the detector may also miss some real positive and negative strain peaks by recording a signal per 6.1 odd times 10 to the negative fifth second. That's like a 6/10,000ths of a second, as in every peak would occur with that frequency. Therefore, correction time of strain peak within the range of error has many kinds of accessibility values. Table 1 lists the time of the positive and negative strain peaks corrected by numerical approximation, and the time for the 2 wide positive strain peaks that have not been determined is represented by x sub 5 and x sub 7 respectively, and the time for the 3 wide negative strain peaks that have not been determined is represented by t sub 3, 7, and 8 respectively. The intrinsic period and the intrinsic frequency are defined as t sub n equals t sub n minus t sub n minus 1, and function of n equals t sub n to the negative 1, respectively, in which the subscript n is also quantum number and arranged in reverse chronological order. Finding the minimum solution of the Diophantine equation system, which accords with the physical meaning, can be determine the best approximation equation of the quantum law, and the resulting from Los Angeles, and the resulting Lagrange frequency change rate of the positive and negative strain from the GW signal is the same. I love that hyphenation of studying. That's beautiful. Studying the simplest calm quantized oscillating function, y is sine of 2 pi onto 1 plus 5t times t. I don't know why they throw the t back over the 2 pi. That's kind of tangent. With high frequency approximation shows that the same change law of positive and negative strain peak time is a kind of high frequency effect. But when the frequency is low, the time distribution law of the positive and negative strain will show a significant difference. And here we are looking for the x sub 3, 5s, and 7s. They're not even labeled, but whatever, we'll go with it. At least it's in color.
Yeah. That's interesting.
Points for a color diagram, buddy. That's awesome. So 21st century. The GDub waveform belongs to the high frequency signal wave. Being similar to the Lagrange frequency change rate, the ratio of the function sub n plus 1 function sub n to the negative 1 of the adjacent frequencies of the positive and negative vibration peaks of high frequency signal waves is decided by the quantum number n. Because the exact function of the frequency function sub n can always be expressed to be the Lorentz series on the quantum number n onto the function sub n to the negative 1, positive 1, is the ratio of the two Lorentz series. Referring to the spectral law of hydrogen atoms, other small frequencies can be determined by using the maximum or higher frequencies. So the other smaller frequencies can be determined by the maximum frequency. The two series of series are truncated, and the approximate rational formula of f sub n plus 1, f sub n minus 1, to the negative 1 rather, is a nonlinear recurrence equation with no simple function solution. After the truncation of the series, the retained terms can be the same or different, but the approximate rational formula obtained by the truncation series must conform to the following physical meaning. Same equation function sub n is a monotone decreasing function of quantum number n, otherwise 0 points and singularities destroy the radiation rule of binary stars. And there is a quasi-quantum number problem which can lead to a similar black hole horizon situation. The larger the quantum number is, the closer the adjacent frequency is. And so there is a limit value of limit as n approaches infinity, function onto n, just like you saw, equaling 1, which indicates the highest power of the numerator and the denominator of the function 1 to the negative 1, etc., are the same, and the coefficients of the highest power term are the same. The approximate formula of the adjacent frequency ratio of the GDub signal, which satisfies the above two conditions, is the rational formulas of the coefficients to be determined. Here we take the following form, and I'm not going to read equation 1, it's a hoopy, and you're just looking at the distributive property exponentially there. Down below table 1, a whole bunch more of the same thing of the distributive property, as you're seeing exponentially delivered through the function. For the same number of quantum numbers, ratio of the adjacent frequency or period of the positive and negative strain peaks of the GDub waveform are the same. So the undetermined normal strain peak time of x sub 5 and x sub 7, can you zoom in like one tad? And the negative strain peak time t sub 3 and t sub 7 satisfy the following equations respectively. Okay, the first equation gives x sub 5 at 0.38, etc. to second. Again, what is it? 3, 6, no, those are billionths of a second we're quantifying there, guys. And the second equation gives t sub 3, 0.0418, etc. So the two period values to be determined here are respectively a t sub 4 plus is the positive value, as guess t sub 4 is 0.01709, etc. seconds, and the t sub 5 positive value is 0.022, etc. seconds, and the the two undetermined negative strain periods are t sub 2 negative 1 is 0.07329, etc., and t sub 3 negative 0.01077, etc., respectively, seconds. Substituting the periods or frequencies corresponding to the first few quantum numbers into the equation 1, one gets a system of Diophantine equations for 9 irreducible unknown parameters. Where A, B, C, D, E, F are all undetermined constants pulsing the undetermined normal strain peak time x sub 5 and x sub 7, or negative strain peak time t sub 3 and t sub 7 in table 1. There are 11 unknown parameters, and the reduced parameters after reduction are 10.
Dude, who cares? Just some unknown
Among,
params. Just
among
just
them,
take a stab in the dark.
there you are, a little higher, more among
So,
them.
is this in regards to how they have to like linearize the equation so that they can solve it, like make approximations? Is that kind of what's going on here? And they're just like, you can just adjust these to
I'm
solve it.
busy reading it, so I'm not actually quite following it the way that I should. But all of this really heavy-duty billionth of a second resolution here is pretty pretentious. But
Yeah,
the
indeed.
nerds love those decimal points, so I don't know what to think, really. I mean, there's just so much error possible when you're dealing in billionths of a second. Among them, the last equation is used only to determine the strain peak time. The general solutions of the Diophantine equations, composed of the first 4 equations, are expressed by A, B, and K. And okay, so we'll get down here when K is 32 and A is 168 and B is 279. Bingo! The above new system of Diophantine equations has the minimum positive integer solution C's 143, D 216, E 471, and F 333. By replacing these coefficients into the equation 1, the simplified formula for the calm quantized frequency recurrence equation is determined. Suchly with equation 3. And again, you're seeing it binomially stripped across. According to the last equation 2, it can be solved for the positive strain peak time x sub 7 at 0.03355, etc., seconds, and the negative strain peak time x t sub 7, yes, at 0.351, etc., seconds. And the corresponding periods are t6, the positive value, 0.027 seconds, t6, the negative value, 0.023 seconds, respectively. These values are in the range of error, as in within the margin, I think is what he means. Recurrence equation 3 is fitted by the frequency of the GW waveform. In equation 3, calm quantum law is satisfied by the frequency change rate of GW waveform can be derived by a simple algebraic operation. That's a relief. And the derivation process is omitted here. Thank you so much. Recurrence relation of third equation is a more basic calm quantum law for spiral systems. But equation 3 is not the only best approximation, and other approximations can be fitted. The numerical results of the same quantum number are necessarily consistent with the error range. Because the quantum law is succinct and graceful, and the binding system has obvious quantum characteristics when the quantum number is small, therefore it is reasonable to use the possible small natural number to fit the distribution law of the discrete physical quantities as small as possible. The simplest form of undetermined characteristic recurrence equation can be conjectured according to the characteristics of frequency distribution and variation of the signal wave. The minimum solution of characteristic Diophantine equation system can be determined by numerical analysis, and then the specific equation can be determined, in which elimination of 0 points and singularity points is the key condition for fitting the equation. The fitting of best approximate equation often requires repeated approximation. From a practical point of view, if that the numerical calculation results are in conformity with the experimental observational data, or the curve of the numerical equation is coincided with the curve of the functional equation, is considered as the standard, it is completely able to accept the reductive numerical equation for eliminating the 0 points and the singularity points in the operation process. All right,
Good
section
grief.
3. Thanks, man. Calm quantum numerical theory standard waveform. Using the frequency recurrence relationship of the GW waveform, a standard waveform can be drawn and compared with the so-called numerical relativistic waveform of LIGO. The editor of Physical Reviews He believes that a simple quadratic fitting can also well estimate the strain of the GW waveform, so it is not necessary to draw a standard waveform by fitting the accurate law of the GW signal frequency. Only after practicing it in person can we know that such speculation out of thin air is not only untenable, but also covers up some important truths. Period or frequency of signal wave of change frequency is a continuous function of time. It is difficult to determine the 0 point of GW waveform and other specified strain time directly. It can be seen that drawing the numerical relativistic waveform needs an open, transparent, and clear data processing procedure. This section introduces the numerical fitting method and drawing procedure of the COM quantum theory standard waveform whose frequency distribution meets the recursive equation 3. The specific operation also needs the help of Excel. Woo! Let's hear it from Microsoft. Although the content is cumbersome and difficult to master quickly, we will be able to experience the calculation process required to draw the numerical theory waveform so as to reflect on the opacity of the so-called numerical relativistic gravity waveform in LIGO and see through the intention that LIGO team apply to colors to a drawing by irrelevant something factors, I bet. To a drawing by irrelevant factors to describe the GW waveform, deliberately to make things look mysterious so as to divert readers' attention to the greatest extent, so that if the reader does not blindly follow the trend, he will expose his lack of knowledge and produce a sense of inferiority. Oh, we can't have that.
That still works.
Ooh, I had to put
This is
another one in there.
hilarious.
According to equation 3, strain time in other periods can be calculated by using the strain time of the phase difference of 2 pi in the two adjacent periods. Using the definition inversion of the period t sub n equals t sub n minus t sub n plus 1, this time satisfies the recurrence relation t plus or minus sub n equals t plus or minus sub n minus 1 minus the function of plus or minus function of n minus 1 to the negative 1, which is replaced by the equation 3. You read etc. in equation 4, and you can see he's binomialing. He's getting all quadratic there. By table 1, T1, the positive, is 0.428 etc. seconds, and the T2 positive, 0.423 seconds, gives the positive strain peak period T sub 1 positive of 0.05 seconds, n equals 1. T sub 2 negative time is a 0.42596 etc. seconds, and the T sub 2 negative 0.43029 etc. seconds gives the negative strain peak period T sub 1 negative value 0.00433 etc. seconds, n equals 1. From this, the difference equation of positive and negative strain peak time is obtained as follows, and that's all of equation 5, with a massive summing of the functions, all quadratically condensed, and exponent to the positive and the negative. All right, the time of other positive and negative strain peaks can be calculated by using the equation 5. Table 2 lists correction times for the 11 positive strain peaks and 11 negative strain peaks of the GW signal, including the corresponding frequency and period. Referring to Planck-Bohr's hypothesis of quantum mechanics, if it is determined that the energy of gravitational wave is an increasing function of frequency, and assuming that the strain of gravitational wave laser interferometer comes from the action of gravitational wave, the amplitude of the signal wave should also be an increasing function of gravitational wave frequency. Did you guys get that? Just kidding. If GW waveform is gravitational wave, then should the abnormal part of the main vibration in the GW waveform be interpreted as the waveform distortion caused by noise, or the systematic error intentionally left when extracting the waveform, or accidental error? And this guy really needs to go to like sentence construction school, because that's not a question. Anyways, I guess maybe it is. So many parenthetical interrupters in there. You get dizzy. It is analogous to the representation of electromagnetic wave energy. If the gravitational wave energy, epsilon, is directly proportional to the frequency f, that is, epsilon is, I guess, proportional to f. Is that his cute little sign? Then, because the energy of the gravitational wave is proportional to the square of the amplitude, it is further conjectured that the energy distribution is proportional to the square of the strain, as in epsilon being proportional to h squared, so h proportional to the root of epsilon, proportional to the root of the frequency. From this, h sub n is proportional to the root of function sub n, h sub n plus 1 proportional to the root of function sub n plus 1. In this way, two strains, h sub n plus 1 and h sub n, with the phase difference of 2 pi, satisfy the relational h sub n plus 1 equals, function to the negative 1 like we saw above, to the exponent of 1/2 times h sub n. That is, h sub n into the function to the negative, like we saw, to the half in the form of equation 3. And then from the equation 3, one gets the result in here in equation 6. And he's multiplied out his coefficients. Equation 6 is only a semi-definite quantitative equation based on guesswork rather than a numerical fitting equation. In fact, it cannot be proved to belong to a precise natural law at present. It is listed here only because the strain relationship it gives is in accordance with the traditional understanding and can be used as a reference for quantitative description. So it's a bit like Feynman. The numbers are right, but that's about all you can say about it. Equations 5 and 6 are applied to the GW waveform. First, the time of the next several positive and negative strain peaks is calculated by the recurrence equation 5. The time of each period is divided into 400 equal parts with different time intervals. Then, correction values of 400 positive and negative strains of n equal 2 are determined by the cosine function. Then, the positive and negative strains of other periods are calculated by semi-quantitative equation 6. It is necessary to select the appropriate starting time and ending time. Otherwise, the calculated strain distribution will be deformed in the waveform. In 2016, I used Excel to generate 4,000 groups of GW waveform time strain data. The Excel file is called COM Quantum Waveform Data of the GW Waveform 2016. It should be noted that more data can be generated by computer, and different generation superposition can be also scrambled to imitate observation data. Therefore, we have reason to suspect that some unrepeatable experimental data may be forged. The COM quantum theory waveform shown in Fig 2 is drawn from 4,000 sets of data. In order to compare the different waveforms of the GW waveform, Hanford waveform, Livingston waveform, and numerical relativistic waveform are also drawn. The COM quantum theory waveform in the high frequency band is consistent with the numerical relativistic waveform of the GW waveform, has no transparent drawing procedure. The fundamental reason for the difference between the two waveforms in the low frequency band cannot be found at present. LIGO's conclusion has always been the lack of scientific reasoning, I'm guessing. Lack of scientific... Where the hell did you go with that one?
Integrity?
Something. Top of the page. Reasoning. Hey, I got it right. Vague and reckless. I love it. Yeah, just on Fig 2. Good. Drawing of the COM quantum waveform of the above GW waveform has a clear numerical processing procedure. Drawing the COM quantum waveform of the variable frequency signal wave, including modifying the strain time of the waveform to fit an applicable waveform function within the allowable range of error, requires determining the quantization formula of frequency distribution of variable frequency signal wave to different variable
wait. I
frequency
want to slow
signal.
down on that. Hold on.
Okay, drawing the COM quantum waveform of the variable frequency signal wave, including modifying the strain time of the GW waveform to fit an applicable waveform function within the allowable range of error, requires determining the COM quantization formula of frequency distribution of variable frequency signal wave.
I want to say, yeah, That's kind of
It's a
their
mouth.
trick. It seems like they
This
have
is
like
even
they have like sliding windows at both of the observatories, quote unquote. Um, and every time that they say that they observed something at both of them, they always are like not actually lined up in time. Like everyone, the big trick is like, oh, we know that the black holes merged because we found them in at both of the LIGO observatories at the same time. But what he's saying here, as far as I understand, is that they actually have like a sliding scale, and they just kind of fit it in where it makes sense.
Sounds about right.
So
yeah, it would be a window of time from the first detector to the second detector because it's a ripple, right, propagating at
yeah,
sea.
and they don't really care
So
how big or small it is. They're just like, yeah, it happened sometime within
yeah,
this window, and there you go.
yeah,
You're
dude, this is
insane.
even crazier than I thought for how they're deriving this. This is exactly the kind of stuff that Dirac was like, I don't want
I'm
any part
out.
of this. Yeah, this is
Yes.
insane, dude.
To different variable frequency signal wave of natural phenomena, any new effective numerical method will prompt the discovery of new discrete laws. And that's exactly what we're covering here, new discrete laws. What an awesome term. Scientific conclusions should not be confined to qualitative descriptions. By trying to draw a numerical relativistic waveform of a LIGO signal wave, we can infer the reason why the drawing procedure of the so-called numerical relativistic waveform of the GW waveform is opaque. This is because drawing the numeric waveform requires the corresponding numerical equation rather than the original function of the expected waveform. In a word, the drawing of numerical theory waveform can greatly reduce the empty debate about opaque operation and can also discover the precise rules hidden in the observed data in the process of improving the numerical calculation method. Isn't that fun? Chapter 4. Section 4, I guess. Our bedtime story tonight, boys and girls. Missing characteristic frequencies of GW waveform. The system of spiral binary stars is the simplest and most important model of the gravitational wave source. Modern gravitational theory holds that the merger of binary stars will undergo these three processes: inspired, merger, and ring down. Various LIGO signal waves have been corrected to give waveforms that meet the theoretical expectations. No. However,
I wouldn't
from
be
the main
surprised.
vibration part of the various LIGO signal waves, only the strictly monotonous frequency of the GW waveform is most consistent with the characteristics of the gravitational wave of the spiral binary stars. According to the correct superposition curve of the Hanford vibration curve and the Livingston vibration curve shown in figure 1, it is easy to find that the Hanford vibration curve of the 0.43 seconds to 0.4 seconds roughly does not coincide with the Livingston vibration curve after upside down inversion and translation. And even some strain phases are opposite. Oh God, no. Tell me no. This detail may imply important scientific reasons to be discovered. If we can't give a reasonable expectation for these questions and arbitrarily define the GW waveform as the gravitational wave of spiral binary black holes, it is obviously not a scientific conclusion. Anybody pay attention yet? All you nerds, there it is. Now let's discuss a more critical question. Even if the GW waveform really comes from the gravitational wave radiation of merging spiral binary stars, the frequency of spiral binary stars precession increases monotonously, and the frequency of the gravitational wave radiated by the binary stars also increases monotonously in the precession process. However, the frequency of the binary stars' precession will not increase infinitely, so the gravitational wave of spiral binary stars must have a frequency limit, which is expressed by F sub O. In this case, F sub 0 is the characteristic frequency of the gravitational wave spiral binaries. That is the connection frequency between precession process and oscillation process, which corresponds to a special pulse in the gravitational wave of spiral binaries. Special waves. Whether this particular pulse exists indicates whether the spiral binaries have finally merged. That's the punchline. According to the definition of the Lagrange frequency, the change rate of what's change f sub n, is that the dot over it, or is that just a dot in the some
Yeah, it looks like
schmutz
a
in the
dot.
paper with some schmutz there, or is that just the change rate f sub n?
I think you got schmutz a couple of times. So
It's the conspicuous looking piece of schmutz there. Anyways, okay, the period is expressed by the corresponding frequency and the relationship of schmutz f sub n, and there you go again to the -1 exponent is obtained. Although f schmutz sub o has no meaning, schmutz f sub 1 has the corresponding calculation results. So if n equals 1 is taken, then what is that? F sub o is defined. Solving the equation schmutz f sub 1 equals f onto o minus 2, to the -1, the physical meaning of the root is an f sub o equals 1 over 2 f sub 1 onto this entire massive set of parentheticals, half of it rooted and squared within itself, which is really, oh God, I hate when they do that. Anyways, where schmutz f sub 1 equals 1407 f sub 1 squared over 1160 is given by the Lagrange frequency rate formula of the G waveform. F schmutz sub n onto this massive thing to the f sub n squared, then the values of f sub o plus or minus can be obtained. I guess that's to the plus or minus exponent. Can be obtained by calculating the frequencies of f sub 1 to the plus minus and f sub 2 to the plus minus in table 1 respectively. The frequency recurrence of equation 3 can also be used to calculate the characteristic frequency of f sub o to the plus or minus exponent. The form of equation 3 is derived from the recurrence of high frequency and low frequency, which can be rewritten into the recurrence from, form from high frequency to low frequency, f sub n, and there he is getting all quadratic again, multiplied by f sub n plus 1. Take n equals 0 and get f sub o equals 333 f times f sub 1 over 143. The merger of spiral binaries will inevitably radiate positive and negative pulse strains corresponding to the maximum frequency f sub o. The results calculated by the two methods are consistent, and the calculation by equation 3 is simpler for the G dub waveform because f sub 1 positive is 197.39, etc. hertz. Again, going to the 10 millionth decimal place of a frequency per second. And f1 to the negative value, 230.76 odd hertz. So there is your f sub o positive and negative values of 459.67 and 537.36 hertz, respectively. This indicates that at least a special pulse corresponding to the cohesion frequency f sub o positive value is 459.67 hertz should be radiated during the spinal binary stars merging of the G sub waveform sources. The gravitational wave pulse corresponding to the characteristic frequency is the main sign of the merger of spiral galaxies, spiral binaries. Binaries. They're not binaxies, they're binaries. Okay, however, there's no pulse corresponding to the characteristic frequency in the detection data of GW waveform. LIGO claims that Hanford detector and the Livingston detector synchronously detected the GW waveform within 0.25 to 0.47 seconds. Within a quarter to a half a second is what they're trying to say. My cats are going crazy on this. So the problem is suddenly enlightened. In principle, it is impossible for the two detectors to consistently produce systematic errors so that the special pulse marking the merger of binary stars after 0.43 seconds disappears at the same time. So, does the data extraction template lead to the disappearance of characteristic frequency? Or the data extraction is correct and the result just proves that the binaries of the GW waveform source have not realized the final merger, and the binaries of the GW waveform source are still in. The new problems caused by the failure of the final merger of binary stars are: will the binary stars maintain a uniform circular motion? or move away after reaching the nearest distance. What is the shape of the gravitational wave after the binary star reaches the nearest distance? Where was the binary star of the G-dub waveform later? It can be seen that LIGO absolutely wants to create all binary star merger events. Otherwise, the detector can repeatedly detect the subsequent situation, and all myths and stories will go through. Isn't this the real reason why
Wow.
all reports of LIGO claim that binaries have completed the merger?
This is crazy.
However,
Sorry to
if the
interrupt.
G-dub waveform is defined as gravitational wave of spiral binary stars, the merger of wave-source binary stars has not been completed, which is completely contrary to the conclusion expected and announced by LIGO. Now, let's look forward to LIGO's wonderful explanation. Can't wait. The conclusion of human reasoning is about ancient cosmic events is restricted by physical and logical tools. From the G-dub waveform to the G-dub 1700817 signal, LIGO always gives highly repeated conclusions. The extracted signal wave is either the gravitational wave of the merger of binary black holes or the gravitational wave of the merger of binary neutron stars, which means that there seems to be a heyday of the merger of binary stars in the historical process of the evolution of the universe. Its radiation information can be accurately captured by the LIGO detector.
It's just a convenient time for LIGO, baby.
If this is true, how to explain this special cosmic history? However, the G-dub waveform does follow a new quantum law, which contains enough logical propositions. It brings us many thought-provoking scientific and ethical problems and will also promote the progress of physical theory and signal detection technology. Conclusions. Oh boy. Nature always beats hearts. That's got to be something that's not translating well language to language. Scientific
I don't know. I feel like he
researchers.
nailed it.
Yeah, I
Really
don't know.
resonates.
I'm with Alan.
I think you're
I
off on
love
this
it.
one, man. Look, you know what my grandpa always said: nature always beats hearts. So
Scientific researchers must understand especially that the human brain can complete all its functions, but it must have enough awe and respect for nature after all. The LIGO team invariably announced that the information of the merging of one ancient binary after another was just captured by two expensive detectors, which were really very tiring. However, the detection of gravitational wave or simulated gravitational wave will promote theoretical physics to a new stage of development. Gravitational wave signal or simulated gravitational wave signal contains new physical information about quantum theory and many scientific problems that need to be solved urgently. Spiral binary is the simplest model of the spiral system. According to the detection data of spiral binary stars, the quantized recurrence equation of radiation frequency can be fitted by minimum solution method of characteristic Diophantine equation. From this, the quantum number corresponding to each frequency can be determined, and the characteristic frequency of binary star merging can also be calculated theoretically. The quantum law of the G-dub waveform and the frequency recurrence equation of quantization belong to the experimental law. The characteristic frequency of spiral binary stars, which is the only sign of a binary merger, is one of the necessary corollaries of the experimental law. However, there is no radiation pulse corresponding to the characteristic frequency of the binary stars merging in the observed data of the G-dub waveform. Finding out the reason, whether the signal wave extraction template fails to include the peak marking the merger of spiral binaries, or whether the binaries may not. Where are you going?
My bad. Sorry.
Let's see. With a little period, but a black constitution. Where the hell did I just finish that? So I hit a may not. There, may not achieve the final merger. The answer is not clear at present. There we are. So hitting that again. Finding out the reason, whether the signal wave extraction template fails to include the peak marking the merger of the spiral binaries, or whether the binaries may not achieve the final merger, the answer is not clear at present. As a gravitational wave, the final result of binary black holes with the G-dub waveform source needs further analysis and demonstration. If the G-dub binary stars did not merge, the detection of gravitational waves for the later period of the
Yep.
G-dub binary black holes constitutes a decisive experiment to test the theory of gravitational waves and the competence of gravitational wave detectors. Is there any possibility that the source of the G-dub waveform is dense binary stars with smaller mass in the near space-time or some other similar wave source? In fact, it is difficult for humans to truly understand the gravitational system of 1 billion or billions of light years away. Any qualitative conclusions about the cosmos in ancient distant time and space eventually need to be examined by in-depth calculation. As we all know, orbit and period of planets and so on. The classical gravitational theory describes these conclusions of the gravitational system accurately, and the application of classical gravity theory to aerospace engineering has also made brilliant achievements, including the singular conclusions cited through 32 to 36 on those papers, such as a black hole. Some conclusions of modern physics still need to be tested by extensive formulaic experimental laws and logical demonstrations. Hear ye, hear ye. The mathematical forms of different theories describing the same natural law may be totally different, but for the analysis of experimental detection data, their numerical results must be consistent within the error range. And he keeps using that expression, and what he really means is within the margin of error. Studying the law of the fundamental characteristic of physical quantity of gravitational waves, such as the frequency and so on, an accurate theory must not depend on unproven assumptions. Hear that, LIGO? Its correct development is bound to be compatible with the achievements of classical physics and modern physics, especially to accept the test of formulaic exact experimental law. Gravitational waves in general relativity are often described as spatiotemporal ripples, which make them very mysterious. In fact, the essence of gravitational waves is the manifestation forms of gravitational field changes caused by moving objects. So gravitational waves are ubiquitous, but it is usually difficult for gravitational waves to be detected by instruments. Funny how that is. In the laboratory, the simulation spiral motion or other variable frequency motion can be achieved to obtain the corresponding gravitational waves. Since the universal gravitational constant big old G can be accurately measured in the lab, people are bound to be able to build similar sensors that detect gravitational waves in the lab. It is suggested that gravitational waves of spiral systems should be widely simulated in the lab. The observed results of gravitational waves in the lab are repeatable. Repeatable experimental results can be used to measure the confidence of gravitational waves detected by gravitational wave laser interferometer or other sensors. It is of great significance that the detection results of gravitational waves simulating spiral systems will be a reliable experimental basis for testing different gravitational theories. Boom, chaka, chaka, chaka.
No, this guy's trying to ruin all
It's
of
like, stay
LIGO's
tuned.
funding and fun, dude. They're like, no, don't make us experimentally verify anything. Get out of here. We're just looking in the sky and then making up some math. Get out of here, man.
Damn you and your logical standard.
Good grief. This guy is just a party pooper. We got gravitational waves up the yin yang, binaries,
we
black
could party.
holes, and
We
stars.
could party.
What's that?
I said, oh yeah, we could party.
That was a great insight into the process of, yeah, we detected gravitational waves and general relativity is correct. And it's like, well, how'd you detect that again? Like, what does that mean exactly?
Yeah.
It's like, oh, you just got
Took our
the
model-shaped expectation out of the random
right.
chaos, and there it is, man. And then we adjusted our math to fit.
And the proof that our math fit our adjusted model that we extrapolated out from the chaos is proof that that our measurement was correct and the theory is true.
So
Very crazy.
I don't think we have the time for another chapter of ARP. But if anyone had any final like thoughts or questions or anything they wanted to share, or anything they wanted to watch, we could do something short here.
I think I might have something we could watch. Give me 1 second. An interesting video popped up on the one-way speed of light. I hadn't watched it all. I was saving it for
Yeah, we
later.
did burn through that 9-pager pretty quick, didn't we?
Yeah, we did.
But if we're down to watch that,
Thanks, Stone. That was great reading, man.
yeah, much appreciated.
My absolute pleasure.
I like the bedtime story. Knowing the one-way speed. Yeah, it's 23 minutes. It's kind of long, actually. Never mind. I thought it was like 12. All right. Yeah, we could wrap on that if you want.
All right. Well, all right then. Cool. Thanks everyone for listening in, joining us for Stone's bedtime stories with the assistance of Dongfang. As you saw, the LIGO data or the LIGO gravitational waves that have been detected are theoretically something. That's about it. And likely faked, so that's always fun. So yeah, that's fun to read, fun to learn about. There's much more work from Dongfang. Also, go look through our other videos. We've talked about LIGO a few other times, and we read Crother's paper about LIGO in the past. Danielson, did you want to get in with something or just hot mic?
Oh, sorry about that. Yeah, cheers, guys. Thanks for reading, Stone.
Oh yeah, our pleasure. Sorry, Stone, go ahead.
Think it's a myth.
Cool. Well, yeah. So thanks everyone for listening in. Tomorrow night, join us, Shane. So we've got a 6 p.m. Eastern. You're gonna talk about the what was it again? You're talking about at 6 tomorrow.
What?
Oh, yo.
What are we doing at 6?
I think you scheduled the Ruhif thing on the wrong time.
Oh, I did. Tomorrow should be just meteors.
Okay,
Yeah,
so
tomorrow. Yeah,
8
tomorrow's
p.m.
meteors.
Ether Roundtable, 8 p.m. Eastern. Join us for Shane's gonna do a presentation about meteors, meteorites. That should be cool.
Yeah, next Tuesday should be Ruhif. That's my bad.
Okay, cool. So yeah, join us for that. And then we probably will not be doing an X Twitter space this Thursday. Maybe we'll do like a rogue one, kind of off the cuff possibly, but as of right now, consider it canceled just because it's 4th of July, so it's kind of up in the air of what we'll all be doing. And
consider it rogue.
there you go. So yeah, thanks everyone for listening in, and we'll see you guys tomorrow night. Take care, y'all. Much love, by the way. Thanks again for reading, Stone. It's awesome to get together